Let's solve one more with a similar method. Same method, rather saying. Number 2. We have limit n approaches to infinity, and we have radical cubed, cubic radical, n cubed plus 2 plus cubic radical 2n squared minus 1. Okay, and in denominator we have radical degree 4, and we have 7n to power 5 minus 3 plus square root of n. Okay, so using the same method, we are solving, finding limit. So what is it gonna be? Limit n approaches to infinity. From the first cubic radical, it's gonna be left cubic radical n cubed, right? From the second cubic radical, it's gonna be left 2n squared cubed, right? And divided by, it's gonna be radical degree 4. Here will be left 7n to 5, correct? Plus square root n. So, and this is going to be limit n approaches to infinity. Okay, let me move this because I can't fit everything on one line anyway, so might as well have it organized. So n approaches to infinity, it's gonna be, so here we get n, right, plus cubic radical 2 n to power 2/3 and divided by degree 4, radical degree 4 of 7, and n to power 5/4, okay, and plus n to power 1/2. So what is the result? So when we compare in numerator n and n to power 2/3, we will see that n is much bigger than n to power 2/3. Even if you multiply by cubic radical over 2, it's still n to power 1, put here 1, is much bigger than n to power 2/3. So it's going to be replaced with n. In denominator, since 5/4 degree is greater than 1/2, then the coefficient is going to survive, and n to power 5/4 also going to survive. And we are getting limit n to the limit of n to infinity. What do we have? In denominator we have degree 5/4. In numerator we have degree 1. So since the degree of denominator is greater, then the degree in denominator is going to survive, but numerator is going to be gone, right? So what is going to be? 1 over degree 4 of 7. And what do we have? N to power 1/4, correct? 1 minus 5/4, it's going to be 1/4. So since denominator is going to be infinity, right, because of n to power 1/4, this is going to be infinity, and number divided by infinity, it's going to be equal big, bold, fat, 0. Question number 3. We have limit n approaches to infinity n cubed plus 2n squared minus n cubed plus 3 divided by 5 times square root n minus 1. Okay, since our n is heading to infinity, what do we have here? We are getting in numerator infinity minus infinity, right? And divided by infinity. So we are going to work out infinity minus infinity, bring to level of infinity over infinity. Why we are doing? Because we don't know infinity minus infinity, it's undefined. We don't know how much it's going to be. Let me step back and explain what's how infinity minus infinity is behaving and what's the difference between infinity plus infinity. So when we have infinity plus infinity, it's clearly it's going to be infinity, because positive infinity, positive number plus positive number is equal positive number. In a case of subtraction, is completely different story. Because if we take example with numbers 5 minus 4 or 4 minus 9 at the 4 minus 5, it's completely different story. Let's take example. For example, if I take limit n approaches to infinity, I have 5n minus 4n. It's going to be infinity minus infinity and going to be equal positive infinity. Why? Because 5n, 5 times n is greater than 4 times n. Therefore, we will end up with positive infinity. If I write down limit n approach to infinity, I'll switch positions for n minus 5n. It's going to be infinity minus infinity, and we are getting negative infinity because 4 minus 5, 4 times infinity minus 5 times infinity. Okay? And if we have limit n approaches to infinity, let's say 2n minus 2n, it's going to be 0. Infinity minus infinity, it's going to be equal 0. This is why when we had addition, infinity plus infinity here, in the previous question, it's right here. That's why we could easily simplify, because we know we are going to get positive infinity anyway. But in this case, we cannot follow the same rule, and we need to do some simplifications, okay, some adjustment, so it would be clear what is going to be the result. Therefore, one way to get to solve this situation is use as the formula a minus b, a plus b, because here we have a minus b. So I'm going to multiply by a plus b to get a squared minus b squared, okay? All right. This is how it's gonna work. Let me write down here. limit n approaches to infinity. So square root n cubed plus 2n squared minus n cubed plus 3 divided by 5 n minus 1. Okay, so this is going to be equal n cubed plus 2n squared minus n cubed plus 3 divided by 5 square root n minus 1. I am going to put here limit. So I'm going to multiply by n cubed plus 2n squared and plus n minus. First write down the whole this piece. Actually, yeah, well, I was right. Sorry. Plus n cubed plus 3. So it was two terms with difference. I multiply by two terms with addition, a squared minus b squared. And whatever change I do to numerator, I have to do to denominator. So let me write down n cubed plus 2n squared plus n cubed plus 3. Okay, what we're gonna get? It's gonna be limit n approaches to infinity, and we are getting n cubed plus 2n squared minus n cubed minus 3. If you multiply, square of 1 minus square of 2. Yes? And here we are leaving same thing. Plus 2n squared plus n cubed plus 3. Okay, and this is equal limit n approaches to infinity. So 2n squared minus 3, right? Okay, denominator is the same. 5 square root of n minus 1, n cubed plus 2n squared plus n cubed plus 3. And this is equal to n squared minus 3. Actually, we already can, since we got rid of subtraction, in numerator we don't have subtraction. So because of limit, I can ignore 3 because n squared, we have large enough number, so I can just put 2n squared, yes? Okay, and in denominator, considering square root n minus 1, so n is the enormously large number, so I can ignore minus 1, and I will have 5 n to power 1/2, yes? And then n cubed, I'm going to have n to power 3/2 plus n to power 3 over 2. Where from? So n cubed comparing to 2n squared. So n cubed is bigger, right? Because therefore square root of n cubed will stay, and we will get, let me see, we will get n to power 3 over 2. Same thing here, n cubed, and I'm ignoring this 3. So therefore will be n to power 3 over 2. Yes? So one term is from first square root, and the other term is from the n to power 3 over 2. The second one, it's from this square root, second square root. Okay? And we are getting limit n approaches to infinity 2n squared, and we get 5n to power half times 2n to power 3 over 2. Because those are identical, I mean equal, n power 3 over 2, n to power 3 over 2, we can't drop one of them. We're just gonna add them, and we get 2 and 3 over 2. Okay, now from here, what it's gonna be left over is equal limit n approaches to infinity. In numerator, I have 2n squared because there's nothing else to simplify. And when I'm comparing 1/2 and 3 over 2, right? What is gonna happen? So since we have here multiplication, in the case of multiplication, you can't ignore. You can ignore or drop some value, compare when you have addition, right? So in this case, it's going to be 5 times 2 is 10. And n to power 1/2 times n to power 3 over 2, you are going to get n squared, right? 1/2 plus 3 over 2. And the result is n squared is gone with this n squared. This is 1, this is 5. And it's equal 1 over 5.